So welcome to the Sound Council classroom, and in this lesson we're going to be learning about stereo microphone techniques. Now, stereo is very important, and for this we'll need two microphones. Why two? Because we have two channels of recording, the left channel and the right channel. And we're going to use condenser microphones for this as well, because these are normally distance techniques and we want very high quality. And we're also going to use a matched pair of microphones. A matched pair of microphones means basically the same make and model of microphone, so that they're going to have an identical frequency response and they won't sound different or have different characteristics, and they'll have the same polar pattern. We're going to be using cardioid for most of these, although there are some other polar patterns that come into play later on. The most basic stereo microphone technique is called the XY pair. I like to remember this because the microphones are crossed over like an X. Now the two capsules of the microphone are as close as they possibly can to be and at 90 degrees to each other. This means there's no phase issues. It's great for things like acoustic guitar and small ensembles and horn sections and all sorts of wind and string instruments. The microphones being as close to this are what we call a coincident pair, because they're so close. And it's also important to remember that whilst this microphone here is on the left and this microphone is on the right, they're actually handling the opposite signal. So the microphone on the left is picking up the sound from the right hand side of the ensemble, whilst the microphone on the right is picking up the sound from the left hand side of the ensemble. Let's look at another technique. This is called the NOS, N-O-S, a Dutch broadcasting company technique. And again, it's very similar to the XY pair, only that it's the back of the microphones that are crossed over at 90 degrees this time. And that means that the capsules, the business end of the microphone, is going to be further apart. And in this instance, they're 30 centimeters apart. Worth remembering as well that this is what we call a near coincident pair, even though the microphones are close to each other, but the capsules aren't that close. This time the left microphone picks up the left signal and the right microphone picks up the right signal. It's quite a natural sound that we get from this, although it's a little bit exaggerated in the stereo sound field. It's good for overheads and drums and larger ensembles. The next technique is another broadcasting one. This is ORTF, which is a French broadcasting technique. And again, a matched pair of microphones, again crossed over, but this time the angle of incidence is 110 degrees. Okay, and the distance between the capsules this time is only 17 centimeters. Now this is another near coincident technique that gives us a very natural sound. One of the main reasons for this is because it's designed to sort of emulate the human ear. So the human ear is roughly 17 centimeters apart. Great for orchestral recordings and larger, even medium-sized ensembles, the ORTF. Now, here's a spaced pair, and the spaced pair of microphones are not coincident, okay, as the microphones are quite far apart from each other. In terms of a spaced pair, they might be between a metre or even 3 meters apart. This is quite good for overheads in a drum kit or for very large ensembles where you have a large spread of musicians. It has a very exaggerated sound field, and because the microphones are so far apart, there can be problems with phase, especially if you put both mics panned in the centre. Great for large ensembles though, like I said, choirs, and I use this a lot on overheads on a drum kit. Let's have a look at some alternative techniques that maybe don't use cardioid microphones. Some of them don't even use a matched pair. The first one we're going to look at is a technique called the Blumlein pair. Blumlein, named after a man called Alan Blumlein, who worked for Decca in the 1930s. And initially, this just looks like another XY pair. The microphones are at 90 degrees to each other. And the capsules are designed to be as close to each other as possible, so it's a coincident pair. The difference here is we don't use cardioid microphones. Instead, we're going to use figure of 8 bidirectional microphones. So the polar response patterns look like this. So that's one microphone, that's the left-hand microphone, and then the right-hand microphone. And you can see the crossover of the polar response patterns there. Now, what this means using a figure of 8 microphone is the microphone is sensitive behind as well as in front of the microphone. And that means this particular setup is really nice at picking up the sound of a room. You want a nice room, of course, otherwise it'll pick up the sound of a nasty room, and we don't necessarily want that. Slightly more technical and difficult to understand is the mid and side, or MS technique. So imagine the ensemble here, and we take a single cardioid microphone and we point it at the centre of the ensemble or the instrument that we want to record. So you can see the cardioid polar pattern there. Then on top of that, we add a second microphone, but this one is figure of 8. So figure of 8 again figures in this equation. The figure of 8 microphone, however, is at the side, so the two lobes of its sensitivity are pointing to the side of the ensemble. Now, the cardioid microphone would be plugged into a single channel as normal, and that would be panned in the centre, like this. So that would go into channel 1, for example. But the signal from the figure of 8 microphone is split into 2, or we use 2 channels assigned to the same input. And each of those channels, one would be panned left, and one would be panned right, like this. Now what we do, this trick, if we don't do this, is we flip the phase of one of the channels. So we have to invert that phase. Now there's instructions on how to do this in the Pro Tools pages in the mid and side section. It's a very useful technique. Now what about positioning these microphones? Well, like all microphone techniques, what we have to do is experiment. And once we've finished experimenting, we need to experiment a little bit more. And after we've done that, we can do even more experiments because there's always an individual sweet spot. However, let's look at a couple of basic rules. Let's use the example of an acoustic guitar with an XY pair. So here's my acoustic guitar. And then in front of that, I'm going to put a straightforward XY pair of match condenser microphones. They'll pick up the sound very nicely, and we'll distance those between anything like 30 to 60 centimetres away from the sound hole of the guitar. The closer the microphones are, we're going to get less room sound. The move them further away, we're going to get more room sound. Those microphones are roughly the same height as the guitar itself. What about horn section? So here's my horn section. We've got a trumpeter and a saxophonist who are playing in the studio. And a stereo mic technique, now the XY or the ORTF is pretty good here. So you can see we've set this up, but the microphone stand itself is pretty high and it's pointing down at the ensemble, and we get a really good signal if we do that. So that's it, that's the guide.